which is what I'm going to go through here. Okay, so if I use this second method, the LCD method, okay, what we're going to do is we're going to treat this entire fraction as a whole, and we're going to multiply it by the LCD of every single fraction involved in the problem, top and bottom. Okay, so we need a factor of 1, a factor of x, a factor of x squared, so I need one more to get a total of 2, a factor of x squared embedded already, x embedded already, 1 we don't need. So here's our LCD. Now, if I was looking at this problem, because there's only one LCD factor, this method is probably a quicker, more efficient way to approach it. Okay, so what I'm going to do is I'm now going to work just in my numerator. So working just in the numerator here, I'm going to distribute my LCD through. So here I get 1 times x squared. Here this x cancels with one of these x, so I'm left with a negative 5x. And here the x squareds cancel completely, so I'm left with a negative 24. So I've converted out of this rational form into a single expression. I'm then going to do the same thing with my expressions in the denominator. I'm going to distribute through my LCD. And when I do, the x squareds cancel, leaving a 15. So again, I'm going to write that as my last term. Here, one of the x's cancels, leaving an 8x. And when I distribute here, there's nothing that cancels, so I get a 1x squared. Okay, so I've converted out of this rational form into a single expression, which I can now simplify. So I'm going to factor everything. So x minus 8, x plus 3, factor the denominator, x plus 5, x plus 3, cancel common factors, and I get my answer, x minus 8 over x plus 5. Okay, now, I happen to see in this that x can't be a negative 3. Okay, but here's the disadvantage to this method. So advantage, it's quicker. Disadvantage, you don't get to see the domain restrictions. So if you use this method, you need to go back in and identify all the domain restrictions of each individual fraction. So x can't be 0, 0, 0, 0. It doesn't apply to those two. So do I know that x can't be 0 based on my simplified form? And I haven't restricted it already, so I do need to include that. So either of these methods works. It doesn't matter which one you choose, whatever one you're most familiar or comfortable using.